Hi, everyone, and welcome to SUSECON Digital 2020. You are watching Getting Started with Containers on SUSE, packaging and deploying your first application. This is also known as TUT-1299, so hopefully you're in the right place. My name is Dan Elder. I'm the Linux Services Manager with NovaCoast. I get to play around with this stuff all the time. I'm hoping you're going to find it useful. And if you have questions, please feel free to reach out to me or my very talented co-host here.
And hi, I'm the talented co-host. I'm Brian Sips, sales engineer with SUSE. And Dan and I both are located here in Southern California, but regardless of our time zone, if there's any questions or you have any comments or anything like that, follow up. You can have our email here listed on the bottom of the screen. Please reach out to us anytime.
Excellent. So with that, we'll get started. So just a brief overview of what we're going to try and cover here today is, one, we're going to just talk about container technologies, where they're at, where they came from, learn a little bit more about them, but this will mainly be a review. Then we want to kind of dive into the different options for how to deploy those, because that's really important to figure out and get right. Then we want to make things easier, because this stuff can get down very quickly into the weeds and get complicated. So there's some technologies and solutions out there that can make that a lot easier for you to deploy. And then we're going to talk more about packaging and deploying so you can see how to do that and kind of get started a little bit. And then we're going to have a non-demo demo, and we'll talk about that when we get there. So, container technologies. Well, a lot of people have heard about containers. That's a very big buzzword and has been for a while now. You've probably heard of Docker. You may have heard of some other container runtimes. There's a lot out there, and everyone's talking about containers right now. So what do we mean when we say containers? Because when you look at it, the reality is they're not new. Container technology has been around for a really long time, but some of the big heavyweights like Docker made it easy. And that was the key difference. Containers are not a new idea. They're not even a new implementation, but it took someone to really standardize it and make tools out there that were open source and available for everyone to make them easy for everyone to use. And that's what Docker did, and then everyone grew out of that. So what containers do is they let you package up your application and the libraries to just the minimal amount you need to run that application. And this is different than virtualization. So virtualization is when you emulate an entire hardware level, you have an operating system running on top of that, and then you've got a lot of other things running between you and your application. But ultimately, at the end of the day, all you care about is your application. You want your workload to run, and if we can get rid of those layers of virtualization and everything else, you can run a lot more and do it with less hardware. So containers are...
I think there's one good point that you're mentioning about those containers, and the idea being that they're not really virtualization in a sense, but we are taking an application that was originally written as a single monolith application and breaking it up into smaller, what we would call microservices. And so the idea would be that instead of having a single execution module, you may have many. And of course, when I've got many, then I've got other challenges that come along with how do I manage them and secure them and that kind of thing. But the notion is much, much smaller deliverables and pieces, but cohesively still delivering the same application. Does that sound about right?
That's exactly right. So at the end of the day, our goal is to deliver the same application, but make it much more scalable, make it much more efficient. And like you said, there's different ways we can do that. So it gives us a lot of new powerful tools, but it also does introduce new challenges. So yeah, that's exactly right. We fixed a lot of the old challenges and introduced some new ones. So, you know, yay. But so that begs the question of why do we use containers? And that's a perfect question. Not every application is going to be suited for containers. Some of those really old legacy monolithic applications that have their tendrils into all the different parts of the operating system, those are harder to containerize than microservices and those ones that can be broken up and are very modular. But for those applications that are suited to a containerized environment, it's infinitely easier to scale them up, to cluster them, to migrate them around, whether it's on-premise, in the cloud, local cloud, whatever you want to do. It's just a vastly better way of deploying them. But it also makes things so much easier from a developer standpoint, where you start and you build the exact same container that's going to be used in production. So it makes your testing easier. And then as you roll that up into QA and the prod, You get to work much more closely with your various teams, including your security team. So it's really a far better way of building out and deploying applications in terms of breaking down those silos as well and getting your dev, your security, your operations all on the same page for how these applications are getting rolled out there. So they introduce a lot of really powerful capabilities, but you have to adapt to them. And it's not just tools, it's people and procedures and everything else that have to adjust. So there's definitely some challenges.
One of the things I was just thinking, Dan, as you were mentioning that, because they're broken up into smaller subsets and delivered in that fashion, it also means that if let's say I as a developer have to update a particular line of code or at least a section, I don't have to test and redeploy the entire set of containers that builds on my application. I just have to do that one tiny little module. So from a security perspective, it makes it faster for me to give to my customers the things that would change their code and make it better. But as a consumer, as a customer, I would be able to then receive many, many updates and deploy them more quickly, thus giving myself seemingly more uptime without really doing a whole lot in the whole world of high availability. But just by not having to take down the entire application stack, only that one component that's changing gives me a little bit more flexibility, I think. And I have to expect that I'll have all of my containers sort of changing versions at different rates. And I just need to be prepared for that.
That's exactly right. So that gives you both a very powerful ability to upgrade different modules independently of each other. So you're not tied to these long, very slow maintenance periods where you can't upgrade things very often. In a container world, you want to upgrade right away, but you now have the challenge of things moving at different paces. So,
Good, it's, and we'll talk about that. Good. Yes.
Absolutely. But I mean, you can see how containers have evolved over the years. They've definitely changed and grown up, but it's not containers themselves. It's all the tooling around them that's really evolved and matured because once everyone realized how they could build a container and they built their first container and they deployed their first container, then they had to figure out, okay, what do I do for my next container and my next 100 containers and my next 1,000 containers? And that's where you've really seen everything evolve around this is the containers themselves and the tools around them have really matured and grown to deal with those enterprise-wide distributions. And that's why you see the largest organizations in the world on the internet using everything in containers. So, we'll talk a little bit about where to use them. As you mentioned, microservices are absolutely the perfect use case. And then we're going to talk a little bit about where not to use them. And that's those legacy large applications that don't easily lend themselves to figuring out what it needs and packaging it up. So, that's a challenge there because it's really important to understand which applications you should containerize. Because if you start going after the wrong ones, you're going to spend a lot of time and energy and you might not get a lot of success versus going for that low-hanging fruit of those web apps, those microservices, a lot of those things that really, if they're stateless or things like that, those are fantastic. And you can actually go to a site on the internet. If you look up 12-factor applications, though the more checkboxes your applications meet of those, the better it is for the future, which is containers.
Good.
So we talked a little bit about the security benefits, but in today's modern world, it's really important to understand these because the internet is becoming more and more hostile. It's not getting safer, it's getting more and more dangerous. And you're seeing that all the time where the old threat model would be some kids breaking into your website and defacing it to get their name out there, things like that. The model now is to both deface everything, steal all your data, and then try and burn down everything on the way out the door and destroy you as a company. So security is absolutely critical. So what are the benefits of using containers in this world? Well, first one, if you're doing it right, instead of having VMs or physical systems in production that administrators need to remote into to perform maintenance tasks or do anything like that, containers don't need any of that. You don't log into a container and update it or make changes to it. You rebuild it and redeploy it. So there shouldn't be any access at all to your production environment. There's no remote access for someone to exploit to go in and modify anything because the containers only expose just the application and nothing else, and you restrict it all. So when you can take away all those different threat vectors, obviously you're dramatically reducing the footprint, which is pretty nice. The flip side is that's a change of mindset for administrators who are used to being able to go into production and troubleshoot. You can't do that. Well, you shouldn't do that, I should say. So you have to really think about breaking down the operations and development roles, getting them to work more closely along with security, because these types of things can be addressed far better, but it does require closer coordination and cooperation.
And one thing if I could throw in there, Dan, is that people tend to not do a whole lot of troubleshooting. When something goes wrong or doesn't work, they just redeploy. If it stops working, you might have some kind of restart feature turned on so that it automatically restarts for you. But if it continues to fail, people tend to not do any kind of troubleshooting. They just get a new version, redeploy, or something like that. They don't spend the time because it's just too easy. It's sort of like the way that we download applications on our cell phones and the way we update them. We just pick and we point and we click and they deploy. And so we're taking that sort of approach of ease of deployment, putting that into a production server environment. And then as those little pieces and parts change, or if we run into problems, again, we don't troubleshoot a lot, we just redeploy.
Absolutely, because your production environment is not where you should be doing your troubleshooting. What you should be doing is having all the logging enabled for your application in prod, and you can take that offline and analyze it and then take a look at it in dev and try and simulate it. But yeah, like you said, prod is not where you want to be spending your 3 a.m. troubleshooting sessions at. Just rebuild and redeploy. So absolutely. And that ties directly into the next point here. Ideally, your environment should be stateless so that you can just rebuild and redeploy, and that eliminates things like advanced threats or advanced persistence threats and some of those pieces, because why would you have that out there when there's nothing that can maintain state on it? As soon as it gets rebuilt and redeployed, that all gets wiped out. So that's a really important thing to be able to look at and take advantage of, because it's not saying that there's no state. Obviously, data is going to live somewhere in a database or wherever you're storing some form of state, but the containers themselves aren't it. So I can't put a Trojan in there because it's a lot of times the file system is read-only, for example. So by making it stateless, you eliminate a lot of those threats. And by being able to rebuild and redeploy constantly, and by constantly, you look at some of the Facebooks or the Googles where they're doing it multiple times a day, those threats go away. Obviously, not every environment is going to redeploy that way, but know that those capabilities are there. The other nice thing you take a look at when you're building these containers is when you're building something on top of an operating system in a VM or in physical hardware, you've got a lot of things that go into that. And by default, you want to strip out as much of that as you can, obviously, but it's hard. You might need your backup agent or your AV agent or all these other things running in the background that you really don't need. Those are there to support the operating system. They're not necessarily there to support your application or your workload. So when you eliminate all those pieces, you really get rid of so many attack vectors. So why would there be a compiler within a container, for example? Why would you have a shell in your container? When you start eliminating all these things that attackers could use to exploit, it's really hard to get past that and do anything effective, even if they do manage to find a hole in your application, because that whole tool set that they would normally have if they're attacking an OS isn't there. So by having these minimal images out of the box for your application, it really makes it difficult for an exploit to go anywhere. And then the deployment methodology itself allows for a really rapid response when you do need to apply something critical. When there is some giant security vulnerability that requires upgrading all your Apache instances or rebuilding OpenSSH or rolling out a new OpenSSL library. When you have to do that right now, it's really important to have the capability to do that. You can't spend months in testing because Heartbleed's out and you've got to get that rolled out immediately. And when you've got this entire CI pipeline set up so you can rebuild and redeploy quickly with all your testing built in, you can really get ahead of that curve and not be vulnerable as long as someone else, because a lot of the internet is really opportunistic when it comes to people penetrating into your environment. And so if you're not the low-hanging fruit, if you've got your systems at least patched and you can do that quickly, they're going to move on to someone else. So that rapid response capability is very important. Another really important capability is that audit trail. You want to know what happened throughout the entire life cycle of your application from when a developer first touched it to when it was rolled out to production. Because you're presumably using version control for storing your container build files, your application, all that development path, you can see who did what at every point. That's a lot harder to do when you've got physical systems or VMs sitting out there for years on end that have maybe been upgraded multiple times and there's been staff transitions. You don't know why a config file might have changed in that system a year and a half ago. You don't know who installed this package. It's a lot harder to keep that audit trail available than it is when containers are being built, and you can see exactly who made what change just by looking at the version control system. So you can obviously not do that, but why not take advantage of those capabilities since it's just good hygiene?
Well, and one thing to highlight, and you've mentioned it in pieces a couple times, because our containers run in production in the same exact format and deliverable that they ran in test and prod and all those kinds of, test and dev, you find that you're going to catch things a lot sooner because you didn't have to reconfigure or do something different when you deployed into prod, because the production deployment is identical to the way it was in dev and test. So most things are caught early, but in the end, as we mentioned, prod is not the place to do troubleshooting. Get it back up and running and spend your time in test and dev doing it. And because they're identical, you should expect to find a one-to-one relationship between what you saw in prod and what you would see in test dev.
Yep, that's exactly right. And that's where a lot of problems come in from configuration drift between your dev environment and your prod environment and things not being the same. With a container, it's the exact same container wherever it's deployed. So yeah, you eliminate a lot of those problems, absolutely. And that ties into automation. The whole process should be fully automated, not meaning that there's no human intervention, because humans should approve the various states, but the actual building and deploying and migration between environments shouldn't be someone manually typing commands on a keyboard. It should be, okay, I approve this, and now it's done. So you're taking a lot of that grunt work where it's very manual, it's very time consuming, it's very repetitive, and it's very error prone, and automating it. And then this is an important one, because this is, I can't emphasize enough how great this technology is. Being able to use mandatory access controls to confine things further and really wrap that around both your applications and what's underneath it, because there is still an operating system that has to run these Docker containers. AppArmor is a really powerful tool for that, and I could get into a whole 10-day discussion about that. But it's important to know it's really easy to confine and say this application should be able to read this file, write to this file, touch this network socket, and that's it. And beyond that, it doesn't matter if it's running as root or anything else, it can't escape that AppArmor policy. So and there's other obviously mandatory access control systems as well, like SC Linux, but AppArmor is just by far the easiest to use and human readable audit capabilities. So, yay, we like those things.
Just so happens that TUT-1179 is a session that I've already delivered on AppArmor. And one of my slides, I talk about how AppArmor can manage and help control or contain containers, but it's different than the way it would have been done on a traditional application, but still just as effective. The application still runs, it still lets you use the same kernel, but it's just done a little bit differently. And for anyone who goes and looks at that session, TUT-1179, I have a link to some steps that you can go through to test leveraging AppArmor against the container. And that could run you through the steps to help you understand just how AppArmor would work in a container world.
That's perfect. Yeah, I definitely recommend everyone check that out, because it is a really important technology, and it's there, and it's part of the OS, and it's free. So take advantage of that. So now we get into some of the options around deploying containers, and there's many. So the simple use case is using Docker on your own laptop or your own system, and you get to build it out and you deploy it, and you've got your first hello world Docker container, and that's great. Deploying things locally with just running Docker commands yourself is a perfect way to test things and to build things. That doesn't scale to prod though. When you want to go through all these different environments, you want to automate your testing, you want to automate the whole CI pipeline, that's where things get a little bit more complex. So the first step, and this is where each environment is going to be different, and that's why it's not saying you just need Docker or you just need SUSE or you just need these other things. Building out this automation, this CI pipeline requires a wide variety of tools. And the odds are good you already have some of them in your environment, but you probably not have all of them. And so it's not something where you can say, okay, you just need these 3 tools. It really requires taking a look at what you already have in place and then matching that up with, well, here's the gaps, here's 3 solutions that could fill those gaps for you. Based on the other tooling you have, I think these 1 or 2 might fit better, but you have to kind of fill all those in, and this is not easy work. There's a lot of pieces that have to go in to get this level of automation. So it's really important to understand what you have, what can fill those gaps, and how to get there. And those can be things such as version control. It's going to be really important, obviously, to have version control if you're developing your own applications. But even if you're just using other applications that you're not building yourself, your container environments, Docker files, or all your build scripts or your deployment scripts or your unit tests or all those things, you should have those under version control, because again, we want to be able to see what changed when, so that if something breaks or we're trying to figure out why something was done, you can at least know who to talk to and understand that better. So having version control, so you have that whole history throughout the entire life cycle of your project, that's really important. Your build pipeline tools, there's a lot out there to do those builds for you. And again, depending on what tools you already have in place, what kind of environment you have, there's not a one-size-fits-all. It's very particular to your environment, but you really need something for that. Something's got to handle your builds for you. You don't want to be doing that manually. And then container registries. When we build out these containers, where do we store them? How do we control access to them? How do we make them available? How do we, all those type of things where we don't just have an image sitting locally. Where does the image go once it's built? And then the deployment itself. How are we deploying that? What tools are we using to deploy those containers to the environment? And what type of orchestration and scheduling and management solution are we putting on top of that? Because there's not just one choice, there's many choices. And while I personally think there's some better choices than others, there's a lot out there. So understanding what we have to do there so that we can deploy and scale and keep everything managed and understand, being able to see what's going on in the environment, those are really important.
And some of these bullet points have some solutions that are readily available to most people. So when we're talking version control and things like that, people can leverage GitHub or something like that, a service that's available. It doesn't cost anything to be able to go up there and leverage that. You can entertain other different other cost models with something like that. But there are services available to help you, so that when you're doing this, you don't have to get in over your head and start spending money left and right. You can pick and choose, and GitHub is one of my go-tos for something like version control. Good place, easy place to store things and track versions of stuff.
Yeah, no, that's absolutely correct. With basically all of these tools you need, there's both open source ones you can use on premise. There's open source ones you can use in the cloud. There's paid versions that give you support and an entire distribution of support. So you've got a lot of different choices depending on your comfort level with having everything on premise and you want to keep everything safe and locked down locally, or using the cloud, you want to be nimble, or whatever your driving factors are. There's a lot of choices you can make here. And again, there's not a one-size-fits-all approach. It really depends on your exact needs. So yeah, that's exactly right. So the key is, you've heard a lot of complex things that are needed to support a container environment. And a lot of these are new and different from what you need today when you're dealing with VMs or your existing build and deploy environments, where it's not building a container, it's building a new VM. And you've got all these processes in place for who approves it, and then the app team does this, and you've got runbooks built out for the different stages. And those pieces don't look the same in a container environment typically. So there is a lot of both of tooling and then people and procedures that have to change to really make this workflow as efficient as possible. And so that takes time, it takes tooling, but the good news is there are some great tooling options out there. So for example, we talked about, where do your containers go when you're done with them? One great option that I like to play with is using Portus as your container registry. And one of the nice things Portus has is it has the ability to handle role-based access controls, where that you're not just uploading an image and anyone can access it. You can really put more granular controls on it, integrate it with your standard directory, things like that. So there's a lot of registries to choose from, but being able to have some of those bundled together and made easier for you is a nice way of handling that step, because it is important, obviously, to have a tool to solve that problem. Likewise, the orchestration piece, that's a really critical and really complicated piece to get right. There's a lot that goes into that. Kubernetes is really growing massively. Initially, in the container world, there was a lot of different directions things were going. But thankfully, Kubernetes really has kind of become the standard way forward. And so SUSE luckily has a containers as a service platform that makes deploying it really easy and also supported, which again are really good things because particularly when you're starting out, these are complicated technologies and they've done a great job bundling it and making it easy to deploy and easy to manage. But you're still going to run into one-off problems where maybe I didn't do this the right way. I have a question about X, Y, or Z, or some piece of hardware has failed and now things are in a weird state. So having something supportable like that really helps. And this CaaS platform gives you all of that, and it builds a lot around it too to make all your deployments easier. And so you've got a lot of powerful tools there, from the OS all the way up to Kubernetes to all the containers that come bundled with it to make all these deployments a lot easier for you. Another tool that's really important is your continuous integration pipeline. So that CI pipeline, again, in a lot of environments today, you don't upgrade new versions of applications very quickly. You don't roll out all these things. It's very carefully scheduled, or you might have a quarterly update, or you might have an annual update, but it's all planned very meticulously far in advance. And so it's really hard to upgrade on a dime when some type of security vulnerability comes out, or you want to roll out new functionality to your customers, whether they're internal or external. And that's a really painful process, and it's a really scary process because when you make that upgrade, it's usually a really significant change. By breaking it down in these much more modular pieces, you can roll out changes much more quickly and much more safely and much more securely. But you need some tools to make that easier for you. And so that's where things like the Open Build service, who can handle a lot of the compilation and building your containers for you, or Jenkins or some of these other tools come in that can really automate that build process for you so that it is easy to build new versions and deploy new versions and also test new versions and do all that automatically for you long before it hits production.
Well, and there is a session, Hands-on Lab 1113, that one of my colleagues has put out. He and a buddy of his. It's on SUSECON Digital. I don't know if it's already been released or not, but that's a great little hands-on lab to show you some automation tools. It's leveraging a Cloud Foundry version that we have called Cloud Application Platform. And it gives you sort of an idea of what it's like to automate this kind of service. Now, they'll show you things like taking you from automation as a developer to automate your code so that when you write it, you can push it to a service that then creates the container out of it and then pushes that to a container platform like the CaaS platform that Dan mentioned earlier. But even if you're not a developer, you can leverage the automation piece, which goes back to the previous slide around consistency, which allows you to put sort of rules around how do I deploy containers, who can do the deployments, where should they go, because I might have different container platforms, each running different pieces based on the kind of performance and the hardware that I put underneath. And so that hands-on lab gives you a great little intro to what does automation mean. If you're not familiar with it, great intro to what does automation mean, kind of what does it look like, kind of get your arms around it just a little bit in case that's a new concept for you.
Nope, absolutely. Definitely recommend that because this is a big piece of the overall environment you have to figure out. So it's good to learn about it and see how that all ties together. Another piece, we talk a lot about applications being stateless, which is great. If all you've got are stateless applications in your environment, your life is easy. But the reality is there's still data. Your applications still have a database, or they're still storing files somewhere, things like that. So while the container itself might be stateless, they still have access to stateful data. So you still need somewhere to put that. You need somewhere to put that that's scalable and integrates well with those types of environments. So one good option is Ceph. SUSE has their enterprise storage distribution built around that, and it's a massively scalable software-defined storage solution that you can use as storage for your container environments. And of course, there's a lot of different ways you can do these types of things. But if you're trying to build out an environment that's flexible and scalable, why not use a software-defined storage solution to go with it that can tie into it, and that can give you that flexibility to really grow out and handle wherever your data wants to be, whenever your data wants to be. So that's one that we're fond of. So we're talking originally about building your first application. This is something that's more fun when it's interactive and you're right here in the room with us, but we'll try and give it a little bit of a go just to explain how that works. So when you're packaging up a Docker application, it's when you're starting for the first time, it's simple. You've got a Docker file, which is just a text file with a special format. Nothing crazy about that. And you run a Docker build command when you're done with it. That this Docker command reads that file, does what it says, and builds the application. And then when you're done with that, you run this Docker run command, and that Docker run command then launches the container. And it's really that easy. To start with packaging a Docker application is not a lot of work. So we've got an example here on screen, for example, of a really simple, this is, of course, you've always got to start with hello world as your first application. But what you see on your screen here is a very simple Docker file with about the easiest application you could have. So it starts with from OpenSUSE :latest. And what that first line is telling Docker is that when it's going to build this Docker image or this Docker container, it's going to use the OpenSUSE image, and it's going to use the latest version of that. So I could give it a specific version of OpenSUSE to use, or I could give it, other parameters like that. But I'm starting by taking an existing container and then layering on top of it. And that layering concept's really important because we can reuse what other people have done. They can reuse what we've done, but you can layer these different layers in your container. It makes it much more efficient when you're doing these builds. So each step of this build creates a separate layer on top of that OpenSUSE latest. And the reason those layers are important also is it's really efficient. When I change something in here, the build process doesn't have to go through and modify and go through and do every step again because it's got a layer that already did most of these things. It only has to go through and rerun the commands after where the change was. So Docker is very smart about how it layers those pieces. So in this case, we're starting with the latest OpenSUSE version.
Dan, if I could, that's an important, that hits on an important notion we mentioned earlier, which is all about versioning and tracking your versions of the container or the images that you build, because layering becomes so important, because sometimes a particular version really doesn't lend itself well to layering certain other pieces that you're wanting. So being able to track those versions gives you a chance to modify and specify, I should say, those specifics in this particular file.
Yep, yeah, absolutely. And the order you do these things also matters, because if you're making all your changes towards the top of your Docker file, well, every time you rebuild it, it's going to have to run all those commands after that, the changes you made. So you want to put the pieces where you're really making those changes towards the end as much as possible, so that when you're rebuilding those layers, you're only doing it for the later ones. But yeah, perfect point. But so here we're starting with the latest OpenSUSE image, putting a maintainer name in that doesn't actually affect the build. It's just, again, something for tracking purposes. And then I'm running the zipper command to import the GPG keys. And after that, I'm running a patch command. So I'm starting with the latest version of OpenSUSE. But if that container isn't built upstream at whatever registry I'm using every day, then I'm saying, let's apply whatever the latest patches are. So I could build this container today, and it would get today's set of patches. If I rebuild it tomorrow, it would get tomorrow's set of patches if there was new ones. And because, again, that base image isn't constantly updated. So you'll typically see things like this a lot when you're doing your containers. And this goes back to these things being rebuilt and redeployed all the time. A lot of environments, even if they haven't made changes to their application, they'll rebuild and redeploy daily just to get whatever other updates to anything else their container uses included in there. And then the final piece is an entry point where it's going to echo hello world. And if you know shell scripting at all that's going to do when we run this command is it's going to say hello world, which again is what every first application should do. But so we would take this, we would run a Docker build command against this text file. And when we build that, it's going to say, okay, I've got this new image for you. And we could give that image a name during our build command, and we could say, call it OpenSUSE hello world. And when we're done with that, we use this Docker run command. So if we Docker run and then the name of our image, and we could pass other parameters. This is where things can get interesting very quickly, and it's more fun to show you in a lab. But when we run it, out comes hello world. And that's it, because this is the simplest application, and you really can't even call it that. This is just a very, very minimal use case for what a Docker container does. Realistically, you're not going to just echo something from a shell script. You would start running a web server, or you would start up a database, or you would start up some other process. Because again, it's the workload that really matters. But this gives you an idea of what that looks like at a very simple level. So deploying is when things get more interesting. So we've seen how to build a Docker container, and we've seen the syntax for some of that, and we can show you some more interesting things. For example, what if I need my web server to be linked to my database server, to be linked to my proxy server, to be linked to something else? There's interesting ways you can tie those all together. Docker, for example, uses compose, which is just a YAML syntax file which says which containers go together, how they talk, all the different resources they share, and you can define all those things in a very simply formatted script. And then you can use this Docker compose command and bring up a whole environment at once. And so that sounds probably somewhat interesting to the ops teams. When you look at it from a dev standpoint, your developer can bring up the exact same environment using that same compose file that gets used in production. So that's where you start seeing the real power of this, because as a developer, you might have to requisition 3 different VMs to simulate the prod environment. It ties up a lot of resources, and it's still going to end up with configuration drift. But with Docker Compose or these other utilities like that, you can spin up an entire environment on your dev system, which doesn't take a lot of resources because, again, we're just running the application. There's no OS or anything else underneath that. And we can simulate the entire environment and bring up an entire environment in a dev environment that exactly matches your production environment. So that's the power of something like Compose. And then, of course, once you've got those pieces working, deploying that in Kubernetes is what would come next, and seeing how you can roll that out so that your application can now not just be deployed, but scale and handle all those real-world challenges that a production application should.
And one thing that comes to mind as you described that is that, and it's something that we didn't really mention earlier, since the microservices are all smaller, so we took a single application, a web store or something like that. We broke it up into really small pieces. And so we've got the front end, and we've got the database, and we've got the membership application module, and then we have the affinity module. We have all these different pieces of what used to be a big application. We broke it up into small pieces. And when they run as a container, they talk to each other via ports instead of making internal calls like they used to. So if you're a programmer, developer, you're used to making function calls and everything is compiled into one big giant executable. But in this model, everything talks to everything via remote procedure calls. So the beauty about that, though, is that you build in the notion that something will break and not be available. So as you're trying to build and compose and bring up a stack, some containers may launch before others. And as they start to communicate, they are aware that sometimes the communication is going to fail. And instead of just blowing up, they need to pause and do retries. And there's a whole bunch of other choices you can make. But the idea being, they are built to expect that certain services may or may not be up all the time and to handle it appropriately. And when you're trying to deploy that on the Kubernetes platform, for example, the containers have in this self-ability to recover from failures when they occur.
Yeah, no, that's a really good point, because as you're going through and architecting these applications for a containerized environment, you've got the opportunity now to really do it right and make them so much more robust and self-healing and all those other things that we just didn't have before. So yeah, absolutely. Those new deployment capabilities and ways of making them so they can scale however they want and grow however they want and be much more fault tolerant is really a great capability.
Yeah, and Kubernetes offers some of that real-time scaling, where I can tell Kubernetes, well, I don't just want to deploy one container for the front end of my application, my web application. I want 10 of them. I didn't have to do anything different except tell Kubernetes, I want 10 of them. Oh, well, now I want 7. Well, now I want 20. Well, now I want 3. And Kubernetes takes care of the scaling and the deploying of all of those and the regression of those containers and sort of the killing off of them as I don't need them anymore.
Yep, exactly. So when you've got these containerized applications that can jump into that environment, you can do a lot of really powerful things with them.
Yeah, yeah.
And that's where we'd love to show you a demo, but unfortunately, Demos are really best done with a live audience. We would love to show you how these different pieces work and show you how these get built and deployed and show you how these different tools work around it. But the challenge of doing that remotely in a one-size-fits-all where it's not interactive just make this so much better for more of a one-on-one. So if you are interested in seeing some of these technologies in action, or you have questions, or you want to just kind of kick the tires a little bit, please reach out to one of us because we would love to show it to you. We'd love to answer your questions. It really is very exciting stuff, and it can be a little bit scary at first, but we can walk you through it and show you how it works and get you comfortable and familiar with it. So please don't hesitate to reach out. We'd love to hear from you and love to hear your questions and then show you how it works.
Yep, and our email and contact information is on the first slide. From SUSE, thank you guys for attending SUSECON Digital. Thanks, Dan. Appreciate it.
Absolutely. Thank you, everyone, for attending. I hope you learned some new things. And again, if you have any questions or would like to see more, please don't hesitate to reach out.
Thank you, guys.